Hello everyone, today I had a very interesting discussion with a fellow netizen about the Humo model, which you see behind me. This discussion started because of a video I generated. Let's take a look right now. I have an image. Using this workflow, I can turn it into a singing video. Let's see the result.
The sky is crying blue, it's a way for you.
So, what was the point of our debate? He believed that this result shouldn't happen because the Humo we're used to seeing produces an effect more like this. For example, I have this image here, and the output it generates looks like this.
The sky is crying blue, it's a way for you. The fire in my heart, burning white and true.
When we saw my initial result, it felt very strange. As I analyzed this issue, I realized it was actually due to a knowledge gap. Humo is a reference-based generation model, not an image-to-video model. This means it generates a video by referencing the image. Often, the differences are minor. For example, in this case, the image and the video are mostly identical, with the only difference being that the person is now holding a microphone. The existence of such a difference proves that it is not a simple image-to-video conversion, but a reference-based generation. Through this small example, I want to remind everyone that it is crucial to understand the underlying technology. Your positioning of the model must be accurate. If your understanding is flawed, it could mislead your future product development. The reason we are revisiting the Humo model today is that ComfyUI has officially provided native support for it. As we can see, ComfyUI's official blog has a post where you can download the corresponding workflow. However, I need to point out that the official ComfyUI implementation only supports about half of the model's capabilities. The Humo model actually has two main functions. The first is the lip-syncing feature, which we are looking at now. Its other very important function is multi-subject reference generation. For instance, I could upload a picture of a beautiful woman, a picture of a perfume bottle, and an audio clip. The Humo model can then merge all of them into a single video scene. Currently, ComfyUI only implements the first function. If you want to use this model in ComfyUI, you first need to update ComfyUI to the latest version. Next is downloading the models. You can find the necessary models in the official ComfyUI repository on Hugging Face. The models available include a 1.7b and a 17b version. Generally, we download the 17b model, specifically the FP8 version, as it runs faster. Besides the main model, we also need to download an audio encoding model, which is the well-known Whisper model. After downloading, you should place the models according to this directory structure. It is worth noting that the text encoder and VATI are the same ones used for WAN 2.1. I have also set up this workflow on Running Hub. You can access the platform through Running Hub AI. In the ComfyUI space, Running Hub is probably the best online workbench available, as it is always the first to integrate new extensions or technologies. You can use the invitation link in my video description to register for Running Hub and receive 1,000 free credits. Additionally, you get 100 free credits for logging in daily, which is great for trying out your own workflows. Next, let's briefly break down this workflow. We'll start with the simplest function, the one that resembles image-to-video generation. First, let's look at the main model loader here. I am loading the 17BFP16 model, but I am using a weight conversion node to change it to FP8. We also have the commonly used speed-up LoRA. Here are our text encoder and VAE. Then, we need to load the Whisper audio encoder. Since we want the model to lip-sync, an audio encoder is essential. Here is our reference image, a very beautiful Western woman. Next is the audio processing section. We load the audio here, and to ensure a successful single-pass sampling, I've limited the duration to 5 seconds. The audio then goes through our audio encoder, which uses the Whisper model to encode it. The output from the audio encoder, along with our positive and negative conditions, is fed into the most crucial node in the entire workflow, the One Humo image to video node. This node combines the positive condition, negative condition, reference audio, and reference image all together, generating a new condition and latent space. Here, we can set the sampling resolution and the number of frames for the generated video. The video length is mainly influenced by two key factors, the number of frames and the length of the audio. You should try to keep them aligned. For most audio-driven generation models, we typically generate videos at 25 frames per second. So we set the frame rate to 25. If your audio is 5 seconds long, then the total number of frames would be 25 times 5, which is 125. But pay attention, this number must be a multiple of 4 plus 1. After this node, we have our sampler. Since we're using the speed-up LoRA, 6 sampling steps are sufficient. Let's check out the generated video.
Sky is crying blue, is a way for you.
As you can see, the quality of this video is actually very high. The overall movement and especially the detail in the teeth and the synchronization between the lip shape and the sound are all excellent. And that is our simplest workflow. Of course, when generating, you can also omit the reference image and generate a video purely from sound. That works too. Since Humo is based on Wan 2.1, character LoRAs for Wan 2.1 are compatible with this model. This was a very interesting discovery I made during my testing. For example, I previously trained a Wan 2.1 LoRA. Take a look, it is this one. When I add this LoRA into the workflow, let's see the result.
The sky is crying blue, is a way for you.
The result is fantastic. The character's appearance is a perfect match for the one I just showed you. So this confirms that these LoRAs are fully compatible. The result is fantastic. The character's appearance is a perfect match for the one I just showed you. So this confirms that these LoRAs are fully compatible.
The sky is crying blue, is a way for you. The fire in my heart, burning white and true.
To achieve this, I used a context node. Notice it is called context window. This is a native node in ComfyUI. There are actually two similar nodes. This is the generic one. There's another node that looks like this. From its name, you can see it is specifically for WAN models. So which one should we use? You might think we should use the one for WAN models, since Humo is based on Wan 2.1. However, if you use that node, you'll get an error. So we must use the generic context window node instead. When configuring this node, the most important setting is dim dimension, which must be set to 0. This ensures the sliding window operates on the time dimension. Don't choose any other value. Next is the window length. You can set it to 8197 or 77, as long as it follows the 4NI1 rule. Then there is the overlap. When the windows slide, they need to overlap. Setting it to 16 should guarantee a good result. The official recommendation might be 30, but that will increase sampling time. You can experiment with this yourself. There is another critical component in this workflow. The frame length is calculated automatically. How is it calculated? First, we know the video duration. In my case, it is 10 seconds. Then it goes through this math expression node. My expression is quite interesting. I have 10 seconds at 25 frames per second. So 10 times 25 equals 250. This means the full video needs at least 250 frames, but it also needs to follow the multiple of 4 plus 1 rule. So I take 250 divided by 4, round it up to the nearest integer, then multiply that by 4 and add 1. This gives us a frame length that meets the requirement. The result I get is 253, which can fully contain the 250 frames of video and also adheres to the 4N1 principle. Finally, I connect this calculated result to the frame length input, and that is how we get the effect you saw. Now for some other applications of this workflow, or rather a special style it can produce. For example, what if my input image isn't photorealistic, but a detailed sketch of a character? I can use the same method to convert it into a video. Take a look. The character quality is incredibly high, and it largely retains the texture of the original sketch. But remember, it is not simply animating the original image, it is generating a new video by referencing it. We can also do a 10-second sample, which gives us this effect. It has a great vintage film texture. This shows that different models have their own unique characteristics. When you need to create a video with a specific aesthetic, some models might be a perfect fit. Of course, discovering and accumulating knowledge of these traits requires continuous exploration. That is all for today. What are you waiting for? Go and try it out for yourself. Follow me to become an AI expert.